All right, in this video, we're going to talk about more function basics. I'm going to give you a couple of ideas and things you can do to test out certain functions or forms of the function to see if it does in fact pass the definition and that one element of x maps to exactly one element of y. All right, so functions can look different. As you can see by our three different examples, I have a graph, I have the mapping right here, and then I have a table of values. So I'm going to give you some strategies that are going to help you determine if these are in fact a function. And the first one is if you have a graph, you're going to do what's called the vertical line test. And you're just going to draw a series of vertical lines, either actually draw them or just kind of draw them out in your head there. And what you're looking for is, do any of those red lines touch my blue graph, my blue line, twice? And the answer is no, they never touch it twice. Here it's once, 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 all the way through. So as long as I only touch that line one time with my vertical lines, we can say that yes, this is a function. So let me give you an example of a line that might not pass this. I'm going to draw it in red. So for example, if I had a circle right here, right? And then I were to go through and do my vertical line test, we could see that that vertical line touches my graph twice, which that would indicate that it is not a function. Okay, so those are the two things you're looking for there. All right, this example here, this is what's called a mapping. So if you can notice, this right here goes to two separate elements, right? So I have one element in x going to two separate elements in y, and I have that happening twice right here and here. So both of these map to different y's, and so because of that, I don't have one element in x going to one element in y. I have one element in x going to two elements in y, which would mean no, not a function. Okay. All right, so now let's go look at the example of a table. Now, a lot of you probably think, okay, what I got to look for is, do I have any repeating x's? Because that is the general rule that you learn. And yes, we do have a 1 and a 1. However, this one maps to a 0, that one maps to a 0. So while I have repeating x's, both of these x's map to the exact same y value, so I'm okay here. I still only have one element of x to one element of y. So this one is yes, this is a function. Okay, so be careful. If you use the rule, I look for repeating x's. If I find repeating x's, it's not a function. You got to be careful there, because if that repeating x goes to the exact same y, it is a function. All right, so again, the rule is you have one element of x to exactly one element of y. Okay, and so those are some strategies to help you determine if something is or is not a function. Now let's look at these two functions down here. We're going to state the domain and range. All right, so here's what I know, right? I know that if I sketch a real quick picture of the first one, I know I'm somewhere around -5 down here, and then I go up 1 over 3, so it's something like that. I didn't draw it exactly right. Okay, I didn't draw it super accurate, but I know it's a line because we learned in a previous video what a parent function is, right? I know that this function is going to give me a straight line. Now, whether it's a steep one, a flat one, positive or negative, doesn't matter. I just know I'm going to get a straight line. So what I can say is my domain is going to be my x values. So I know that I can go to the left forever. I can go to the right forever, because if I keep going down, it also keeps going left as well. Okay, so in this case, my domain will be all real numbers, and then my range is the same thing, right? I can, as I move up and down, I can continue to go forever, because both those arrows tell me that they will go forever in those directions. So in this case, my range would be all real numbers. So sometimes if I just look at the equation, the domain and range could be difficult to figure out. So if you'll just sketch a quick picture of what that graph may look like, then finding domain and range will be a little easier. Okay, let's look at example 2 here. We're going to do the same thing. I'm going to sketch a quick picture of this. All right, so I know by this squared right here, I'm going to get a parabola, right? And I'm going to rewrite this a little bit. I got -x squared plus 7. All right, and all I did was move these over. All right, so now if you are familiar with parabolas, you know that 7 is going to move it up 7. So if I come up here, and then normally my parabola would look like this, but this negative right here is going to cause a reflection, and it's going to face it down like that, okay? So now I know my parabola is going to look something like this, and I know this 2 right here not only that negative flips it, but then the 2 also kind of stretches it out a little bit, makes it more narrow. Now, what if you don't know or you're not familiar with parabolas enough to sketch a quick graph like that? You can always just choose a few x values. I'll always like to pick a few negatives, a 0, and a few positives, and then you plug each of those in one at a time to x, and that will give you a very particular y value. And from there, you can just plot those points on your graph, and then you'll have a good idea of where that parabola is facing. All right, so you can always do that if you're unsure what that graph looks like. Okay, so that's how we're going to get the graph. But now let's use the graph to help us figure out what my domain and range is. Okay, so domain's talking about going left and right. So as I look at this, yeah, that arrow goes down forever, but it also is going out just a little bit to the left, right? It's just pointing just to the left, and this one's going just to the right. So we're in another situation where it is going to be all real numbers again, okay? Because I can go right and left forever. Now range is a little bit different, right? Because I can see, yeah, it goes down forever, but there's a very specific height that it can stop at. And if you'll remember, we use this +7 to shift it up 7, so I know that point is going to be 0, 7. Now what my range is going to be is y is going to be less than or equal to 7. So any numbers above 7 would not be included in my range, and any numbers 7 exactly or lower would be included in my range. Okay, so that was a real quick video on how to determine if something is or isn't a function, and then a few strategies on how to find domain and range. All right, hope this video helps, and we'll see you in the next one.